Thanks for tuning in, guys. So we're going to be looking at this agricultural technology question paper. We're going to walk through the entire question paper from question 1 all the way up to question 6. So this is a paper that was written in 2018. Okay, so we're going to walk through the entire paper from question 1 all the way up to question 6. Now, after the cover page, you're going to have a set of instructions, right? This is not for display. It's meant to be read. Just make sure you go through your question page, your instructions for every given paper, right? They're very important, very important. Now, this question paper is divided into two sections, the section A and section B. Just make sure that you answer every question. Okay, so let's go over the first question. Question 1, section A, question 1. So for the first question, 1.1, it's a multiple choice question. Let's check out 1.2. 1.2, we are given underlined words. We need to give or make the statements true. And then the last question in question 1, we have column A and column B. We just need to match out. Okay, so let's go back to the first question, the multiple choice questions. All right, so various options are provided as possible answers to the following questions. We need to choose the letters A to D and write the correct letter next to the question numbers. Okay, so 1.1.1, the is used to remove welding spatter from metal. After welding, there's going to be some material that stays behind, that clogs up or piles up after the welding work, right? So here the is used. What is actually used to remove the spatter from the metal? We are given 4 options. Is A the answer, a prick punch? This is incorrect. Why? Because a prick punch is not used for removing material. It's only used for marking metal before the drilling process, right? But not for removing material. So we want something that is actually used for removing the spatter from the metal. What about B? A rasp, a woodworking tool for shaping wood. This one is not actually suitable for removing any material from a metal. C is the answer, an angle grinder. An angle grinder, okay? But why an angle grinder though? So welding spatter is the small material that hardened after the welding process, right? So an angle grinder with a grinding disc is actually perfect for the job, for smoothing the surface post welding. So the answer, the correct one should be C. So for 1.1.1, correct answer is C. 1.1.2, the is used to remove a bearing from an alternator shaft without damaging the components. We have 4 options in acetylene flame, B a claw hammer, C a bearing chisel, and D a bearing puller. I think this answer should be like obvious. Let me say that. It's an obvious one, this one. So D is the answer. Now, why is A, B, and C incorrect? First of all, an acetylene flame is not suitable for the job. Why? Because it could overheat and actually damage both the bearing and the shaft. So we cannot go for this one. What about B? This could also damage the bearing and the shaft through impact. So when using the claw hammer, it could cause some damages as well. So what about the bearing chisel? The bearing chisel could score and damage both components as well. So it's not a suitable tool or method for removing the bearing from an alternate. Now for the 1.1.3, the correct answer should be, you know what, let's go through this. An ideal number of teeth per 25 millimeters on a hacksaw blade used to cut 20 millimeter solid aluminum bar. All right, I'm just giving this one some thought, but you know what? Aluminium, first of all, it's a very soft material. It's very soft, especially when it comes to trying to use a hacksaw blade on it, right? Keep in mind, aluminum, it's a very soft material. It's a soft material, so we cannot use teeth that are longer or short, right? Or short. So we should find that sweet spot, somewhere in between. This is the lowest, the smallest teeth. This is the biggest. This is something closer to the biggest. So the correct answer should be B. This is somewhat ideal. Now, for the A, the 6 teeth per 25, this is too small and would cause the hacksaw to snag and tear the soft aluminum material. Now, what about the C? I'm just trying to provide a reason as to why the A, B, and the A, C, and D cannot work in this case. So 1.2, we are, oh, 1.2 we went with D, and then 1.1.3, we are going with B. We're going with B. C, too fine and could clog quickly with aluminum shavings. That is justifying as to why C cannot be used. What about D? D is extremely fine. D is going to be extremely fine. Extremely fine. Completely unsuitable for soft materials, right? So this is out. This is out. This is also out. This is out. This is too small, right? This is too small. So we're going to go for B. 1.1.4 is used for manufacturing of O-rings. What is the correct answer here? Another obvious one. It should be B. Teflon. It is used for manufacturing what? O-rings. Fiberglass is too rigid and lacks the flexibility needed for scaling. What about C? The Persplex. What about it? Is this obvious though? You know what? I'm going with B for this one. Fiberglass, no. Okay, what about this one? Oh yeah, 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 yeah. Persplex is a brittle material. It's very brittle, so it is unsuitable for compression sealing. So this one is also out. What about Bakelite? Hard, brittle, and thermoset plastic that cracks under compression. So this is not appropriate when manufacturing O-rings. So this one is out of the picture as well. So for the 1.1.4, we are going with B, Teflon. Teflon. 1.1.5, this material should not be grinded with a bench grinder because the material clogs the grinding wheel pores, causing the wheel to overheat. Causing it to overheat. This material should not be grinded with a bench grinder. Okay, so we have 4 materials. That's cast iron, mild steel, and then we also have C, copper, and stainless steel. I'm gonna go with C, copper. Okay, gonna go with C, copper. This should not be grinded with a bench. with a bench grinder. So the other materials can be ground safely with proper techniques like cast irons, mild steel, for example. It's a standard material for benching, for bench grinding. And then C, the stainless steel is also appropriate. It can be ground but requires careful control to avoid overheating. So copper is out of the picture there. It's out of the picture. All right, so 1.1.5, 1.1.5, the correct answer should be C. But you know what? For the multiple choice, I don't think I need to write anything. I can just circle the answers. Okay, so 1.1.6, the use of compressed air in the farm workshop is associated with okay. 1.6, A, soldering, B, MIG welding, C, TIG welding, and then D, plasma cutting. The use of compressed air in the farm workshop. Okay. Let's eliminate the incorrect ones here. Let's start with A, soldering. Soldering. Okay, for starters, soldering does not require compressed air, so this is out. What about MIG welding? So, okay, yes, this one uses shielding gas, something like argon and a carbon dioxide mix. So, no compressed air is required for cutting with this one. So, MIG welding, you are out, buddy. What about TIG welding? Okay, so TIG welding uses inert gas shielding only, so no. Compressed air goes to D. Goes to D, plasma welding. So it makes use of compressed air in the farming workshop. All right, so 1.1.7, incorrect calibration of a diesel pump on a tractor can be identified by 1.1.6. All right, incorrect calibration of a diesel pump on a tractor can be identified. Okay, it's obvious. It's obvious. A, black smoke exiting the exhaust pipe. Noisy valve, no. White smoke exiting the exhaust pipe. Okay, black smoke, white smoke. You know what? The white smoke actually indicates something else, not incorrect calibration of a diesel pump. This in many cases, it indicates a coolant leak or cold start issues, but definitely not a calibration issue. So we are taking this one out as well. What about the engine that backfires? Okay, no, this is related to ignition timing, but not fuel pump calibration. So the correct answer should be A in this case. 1.1.8, modern technological systems such as are used to notify the operator when grain is blocking the system in a combine harvester. Okay, interesting question. Interesting question. Um, okay, modern technological systems such as used to notify the operator when grain is blocking the system in a combine. Okay, you know what? For this one, I'm thinking I'm gonna go with B. All right, let me reason against the remaining options. A, yield monitors. These usually measure harvest quantity but do not detect blockages. So that is why I refrain from choosing A. What about C? Neuron probes. Neuron probes measure soil moisture content. They don't tell us about any blockages. So this one is out of the picture as well. D. Tensiometers measures soil tension for irrigation. So this one is out. So flow sensors, yes. is the correct one. 1.1.9, the drain pipe connecting the toilet to the septic tank is made from obvious one. It's obvious. It's obvious. PVC pipes. PVC PVC pipes. We are normally using PVC pipes for connecting the toilet to the septic tank. Okay. First of all, it's not like we cannot use copper. Copper is it's actually material that can be used for connecting the toilet with the tank. But the problem is copper is very expensive and it can be you know it can be subject to theft, right? So we should avoid. And another thing is that it's actually prone to corrosion from waste chemicals. So definitely not copper. What about latex? This thing is not rigid, so we cannot use this thing. So definitely C should be the answer in this case. Iron, definitely not. Okay, the last multiple choice question. The most suitable all-purpose fire extinguisher for a welding workshop. Okay, another obvious one here. So the correct answer should be the dry powder extinguisher. These ones are not appropriate for putting out welding fires. So the dry one, it's the best option. It's the best option. Now, 1.2, the next part of our question 1. They want us to change the underlined words in each of the following statements to make the statements true. Write only the words next to the question numbers. Okay, so we have a case here. 1.2.1. All right. Okay. So safety signs attached to an electric fence must be made of plastic with a red background. Okay, so let's answer the first one. Safety signs attached to an electric fence must be made of plastic with a red background. Okay, now let's think for a minute here. Red background. So we need to change the underlined words to the correct one. I'm going to say yellow for this one. Now, the question is why? Why? You know what? The red background is incorrect because international safety standards specify yellow for electrical hazard warnings like high visibility and for universal recognition. Now, metal signs are, I'm not sure about the plastic, but you know what? Let's just focus on the underlying words. I think instead of saying plastic, they should have said metal in this case, but that's fine. Let's not argue with the examiner on this one. Let's just roll with the question. Now, I'm saying yellow um, because of standards, not red, but it should be yellow. Now the 1.2.2, a newspaper is the most effective type of communication to inform farm neighbors about an immediate emergency. Okay, this is going to take some time because you need to send out the information to the publisher. Then the publisher will have to write down an article or a story or something like that. And then they'll have to print the newspaper and go and publish. So this is going to take a while, right? It's going to take a while. So definitely not a newspaper. Okay, not a newspaper. So it can be something like maybe a radio, um, even a siren. Even a siren can also be an effective method of communication. I'm also thinking maybe even a cell phone, WhatsApp groups, something like that. that could also work. Now, newspaper is definitely not an option. It's an emergency situation. So the message should get as quickly as possible to the neighborhood. To 1.2.3, a one-way valve is a device that is capable of adjusting the water delivering time in response to current environmental conditions. A one-way valve. A one-way valve. Okay, okay, okay. All right. Um, for this one, I'm thinking a smart controller would do us some good. Smart controller. A smart controller will do a better job in this one. Okay, so so a smart controller, I think it's going to be a device that is more capable of adjusting the water delivering time in response to the current environmental conditions, right? So you know what? Oh, thinking about it, I think a one-way valve, it's this one, it only allows for flow in one direction, so it cannot adjust timing or respond to conditions in an effective way. So I think a smart controller is going to do a better job. So the answer for 1.2.3 should be a smart controller. So 1.2.4, compressed air is used as a hydraulic fuel in a car's bottle jack. Is it? Is it? Is it? No, no, no. It should be oil, a hydraulic oil, hydraulic oil. Even if you wrote oil, I think it's gonna work, but hydraulic oil for a more descriptive answer, it should be a hydraulic oil. Um, well, it should be oil because since oil is standard in all hydraulic jacks and equipment in cars. Now for the last one, 1.2.5. Steel that has a copper coating produces poisonous gases when subjected to welding. Copper. So we need to change this underlined word to the correct one. So no, no, it shouldn't be copper. Shouldn't be copper. Well, copper shouldn't be correct. Shouldn't be correct. Copper, you know what? Copper coated steel exists. But you, sometimes it's for conductivity or corrosion resistance purposes. Yes, but copper fumes are hazardous, but not typically described as poisonous gases in the welding context. So I would say not the most common coated steel in agricultural settings, right? So I'm thinking zinc coating. Zinc coating is the appropriate one. I think it should be the correct one. It's very common in farming applications. So we should go with zinc for this one. We should go with zinc for this one. Let's go with zinc. Now for the 1.3, the column, the matching. Matching. It's time for matching now. We have to choose a word or term from column B that matches the description in column A. We need to write only the letter A to H next to the question numbers. Okay. All right. All right. All right. All right. All right. All right. Now 1.1.1.3.1. Alloy elements used in the manufacturing of stainless steel. I wonder if you guys are doing physical sciences. In grade 10, yeah, grade 10, alloys was a big discussion in physical sciences. The blending or the mixing of metals to obtain a new metal. Alright, so for the 1.3.1, alloy elements used in the manufacturing of stainless steel. Stainless steel, if you know your metals, or if you know stainless steel, it's somewhat a tough piece of metal, and it's also somewhat resistant to corrosion to some extent, of course, right? So we have F as a possible solution or as a possible answer for the first question, and D as another option. So these are two metals that are combined to give us an alloy, right? An alloy, but one of the two should be correct. So the answer here is going to be D. I'll explain why. 1.3.1. The answer is D. It's definitely chromium. Chromium, it provides you know, the chromium oxide layer that actually prevents rust, right? So it provides the corrosion resistance element of the stainless steel. And then nickel on the other side, it's one tough, okay, it's one tough material or one tough metal. So it adds the toughness or the ductility and enhances also the corrosion resistance, right? Now, for the next question, 1.3.2. I feel like I'm not only answering the questions, I'm somewhat giving a bit of a lesson on the side. So just let me know in the comment section if you do appreciate that approach, or should I just go straight to answering the questions? Anyway, 1.3.2, a heat resistant plastic. So these out of the picture. So let me stretch this out. So we have porosity, argon cracking, acetylene, backlight, and perspex. Okay. Okay. Answer should be G. A heat resistant plastic. A heat resistant plastic. So I don't know if you know this, but backlight is the first synthetic plastic and also has excellent heat resistant properties. You know, this is one thermosetting plastic that doesn't actually melt when heated. So it does it does melt, but to a certain temperature, at a certain temperature, at a particular value of temperature. It can actually withstand temperatures to up to 200 degrees Celsius. I'm not sure. Let me just check quickly. Yeah, yeah, yes, yes, yes. Around that range, between 150 and 200 degrees Celsius. And it's also used in electrical insulators. That explains the heat resistance of this plastic. So the answer should be G. 1.3.3, the MIG welding defect that occurs when the gap between the nozzle and the workpiece is excessive. When it's excessive, okay, the answer should be A, porosity. Out. What else is out? G is also out. Now, how can I justify this? Okay, porosity actually refers to gas pockets or voids in the welding bit. Yes? Now, when the nozzle when the nozzle to work distance is too great, shielding gas coverage becomes inadequate, right? So I think, you know what? This is the appropriate one. This is the appropriate one. This is the appropriate one. Me detects, yes, yes, A, definitely, definitely. Then 1.3.4, the gas with the highest cutting, the gas with the highest cutting capacity used for plasma cutting. Argon is a gas. This is not a gas. That is not a guess. That is not a guess. E is also a guess. Okay, it's also a guess. So we have two options, B and E. B and E. So between the two, which one is the correct one? I would argue that E is actually the correct answer here, right? Okay, while plasma cutting primarily uses compressed air, argon, or nitrogen, but the question actually tests the knowledge of thermal cutting capacity, right? So the acetylene has the hottest flame temperature of, you know, about 3,000 or so of cutting fuel gases. So acetylene cutting, this is the high temperature. Now, this high temperature actually allows the rapid pressing and cutting of for plasma cutting. So the answer should be E. 1.3.5 last question. A highly flammable gas that is commonly used in the workshop. That is commonly used in the workshop. Let's see. Argon is an option. Argon is definitely an option. Uh, it's a guess. It's a guess. And then acetylene is also an option. I would also say that E is a highly flammable gas. Yeah, acetylene. A highly flammable gas that is commonly used in the workshop. It's definitely gonna be the acetylene. This is the primary fuel gas in oxy-fuel welding and cutting. So it's a common gas that is used in these types of um, in workshops. In workshops. So E is gonna be our answer for this one. Now, section A, 40 marks. Now we are going for section.
All right, question 2, materials and structures. Now, the question 2 starts section B. So we're going to go over question 2 starting from 2.1 all the way up to 2.6 for 35 marks. Okay, so for the first question, that is 2.1.1.1, they want us to indicate the alloy metal, not just any metal, an alloy metal that is specifically used to manufacture the following products, and give 2 reasons why the material is used. Now, for the first question, what material is used for making milk tanks? Okay, so for milk tanks, it's gonna be stainless steel. Stainless steel is used. Now for the reasons, now there's several reasons, but since they are requesting or asking us to provide 2 reasons as to why the metal is used, I'm going to provide 2 reasons. Now the first reason is that it's corrosion resistant. It is corrosion resistant. So, since we are since the metal is going to be used for milk, for a milk tank, milk contains acid called lactic acid, and is often cleaned with chemical sterilizers, right? So using stainless steel is going to be a better option, because the chromium contained actually forms a passive oxide layer that prevents rust and chemical attacks that comes from the chemical sterilizers. Okay, so the reason why we are going or opting for stainless steel is because of its corrosion resistant. Now, the second reason would be it's because of stainless steel is Okay, let me erase, or let me just say it is weldable. It is weldable. Is this even a word, man? Weldable. Yeah, it can be welded. Or let me just say it can be, yeah, let's say it can be welded well. Okay, let me explain what I mean by this. um Stainless steel, it is weldable, or it can be welded well, meaning that the welded parts of the stainless steel, it ensures that the seams that can be it ensures that the seams can be sealed perfectly during the manufacturing and welding, maintaining a contaminant free environment. So let's say stainless steel, when welded, it makes sure that bacteria or contaminants coming from the outside environment don't have any sort of like holes or cracks that it can seep through um, in welded parts of the stainless steel connections for the milk tanks, right? So here's your 3 marks for providing the answer and the 2 reasons. Next question, 2.1.2, fittings for hot water copper pipes. Okay, the best option for this, it's normally brass. Fittings for hot water copper pipes. Okay, so the fittings are going to be brass. 2 reasons is it's because of their strength. It's because of their strength and their machinability. Machinability. Well, because brass can maintain its strength at very high temperatures, since hot water will be going through the copper pipes. So at the joints you're gonna have, or you're gonna find brass. So since they have higher strength at high temperatures, they can hold their own. Machinability part, now it's because of its easily machined into precise threads and fittings. So it is easier for the manufacturing process to become, a bit easier for the bending, creating threads and fittings, and ensuring that leak-free connections are established. Okay, so that is why brass is a better option. Now for the 2.1.3, we have hammering tools that can be used in explosive atmospheres. I think bronze. Bronze is a better option. So bronze, and the 2 reasons, it's because of its non-sparking properties. Okay, non-sparking properties, and it is corrosion resistant. Okay, look, resistant, corrosion resistant. I think this is a somewhat a common reason that you can provide, especially involving questions that speak about, alloys and stuff. Now, the bronze durability under heavy use while resisting rust in humid and corrosive farm environments. That is why we are saying it is corrosion resistant. Okay, so in the non-sparking properties, they provide us with preventing instances of ignition of flammable gases. If this thing was sparkable, if it was sparkable, it could actually cause explosions if it was next to flammable gases, vapors, or dust found in grains, silos, or fuel storage environments. So bronze is a proper option or best option because it is non-sparkable. So if you had such materials around, it was going to cause explosions and fires. So due to its non-sparking properties, it is a good option. So bronze is our option for 2.1.3. Now for 2.2, name two hot working processes. Hot working processes that can be used to change the structural properties of brass. Okay, this is textbook stuff. Okay, first of all, we have annealing. And we also have stress relieving. Okay, so heating brass above its recrystallization temperature and then, slowly cooling it to soften it. It does relieve the internal stresses and improve ductility for further shaping. Okay, so that is one hot working processes for bronze. Okay, so heating it to a lower temperature to reduce residual stresses from previous cold working, or preventing stuff like cracking or distortion during use. It's for stress relieving. So that is why there are several options that I can list out here, but this is what I can think of right now. 2.3, concrete and fiberglass drinking troughs are used to provide water to farm animals. For the first one, 2.3.1, they want us to give two reasons why farmers would prefer fiberglass troughs instead of concrete troughs for cattle. Okay, first of all, fiberglass, when compared to concrete, it is lightweight, number one, right? So in a farm, I think it is preferable to avoid using machinery, and use labor instead. Why? First of all, it saves costs. Okay, it saves costs. Since fiberglass is lightweight when compared to concrete, I would say I'll provide the first reason by saying fiberglass is because of it is lightweight. So because it can be easily moved around without using heavy machinery, right? So fiberglass, it is lightweight, and it is also durable and rust resistant. And unlike concrete, fiberglass does not crack or freeze. It does not crack in freeze tow cycles, and it also does not corrode and another thing, due to its smooth surface, it inhibits algae and bacterial growth inside, right? So that is why it is an option over concrete. So it is durable and rust resistant. Fiberglass is also lightweight. For the 2.3.2, describe the resin that is used to manufacture fiberglass products. What is it called? What is it called? It's the polyester resin. So now they want us to describe. So they want us to describe the resin. Okay, so let me start off by saying, let me use black, not blue. Let me start off by saying this. Number one, it is a low viscosity fluid that when mixed with a hardening agent or a catalyst, it undergoes polymerization to form a rigid and a durable solid that bonds with, okay, forgive the flashing of my writing. I don't know, maybe the PDF reader is unstable or what, I don't know. Okay, bonds with glass fibers. Now it is ideal because of its cost effective and cures easy at room temperature, and is resistant to water, chemicals, and UV degradation, making it suitable for outdoor farming equipment. So that is the reason, the resin description. Now for the 2.3.3, name two methods that can be used to join fiberglass parts. There's two. Let's see. So we have the following options. Mechanical fastening. Mechanical fastening. That involves things like pop rivets. Hang on a second. Pop rivets. Another option would be, bolts and nuts. All right. So such fastening processes, it provides a strong and reversible joints that can often be used with sealant to prevent water ingress. So this is one option, a mechanical fastening process. We also have laminated bonding as well. Laminated bonding. So this involves a process where we overlap the fiberglass matting with fresh resin. Then it creates sort of like a seamless monolithic joint that is often stronger than the original material. So these are the two methods that can be used to join fiberglass parts. 2.4. Let me try writing this side. Maybe it won't flash as much. Interesting. Okay, so give 5 reasons why Ves- Vesconite is the best material for the manufacturing of bushes. Okay, let's change the color of our pen, perhaps blue this time. All right, so we have point number one. Point number one is self-lubricating. Self-lubricating. Okay, so it contains embedded lubricants. For example, something like graphite, reducing friction without external, greasing. This is ideal in dusty environments where grease attracts grit. Am I saying this right? Yeah. Grease attracts grit. Point number two, we have low water absorption. Low water absorption. Low water absorption. So unlike nylon, which in a case where water is ingressed, it swells, right? So Vesconite maintains dimensional stability in wet conditions. This does prevent seizure on shafts. Yeah, shafts. 3, we have another reason, which is it has excellent, okay, I can excellent, double L, excellent wear resistance. Excellent wear resistance. So when reinforced with fibers and fillers to withstand abrasive, farm contaminants like soil and sand. So that is why it is an excellent wear. It has an excellent wear resistance. So in a case where the soil and sand involved, it is good in withstanding such wear and tear. Wear and tear. So for the fourth one, we have chemical inertness. Chemical inertness. So this simply means that it doesn't easily react with other chemicals. So it resists. It is easier for it to resist degradation from fertilizers, other stuff like fuels and animal waste, which contains chemicals which can corrode the metal or degrade other polymers involved. So it is not so much of a material that can react with other chemicals that easily. So for the fifth point, it has high load capacity and thermal stability. High load capacity and thermal resistance and thermal stability, not resistance, stability. All right, so that is our last point. So I think I'll have to erase some parts here, perhaps this one, this part. Okay, now I just decided to erase everything. Let's see if the fleshiness of the paper won't start again. Alright, now we are at 2.5, not the last question. We still have 2.6, which is the last question for question 2. So 2.5, they want us to describe how an adhesive should be applied to a surface to ensure sufficient cohesion. Alright, so an adhesive, it's something like, that can stick, right? Two materials together, should be applied to a surface to ensure sufficient cohesion, sufficient or enough bonding between the two joining material. So for 2.5, how many marks? 4 marks. Yeah, you know what? Let's start with this one. Let me use another color. Number 1. Okay, I don't need to number this one. Okay, so first of all, we need to start off by preparing the surface. Okay, we can do a surface preparation. This involves cleaning the surface, removing oils and oxidation like rust and all that stuff. The abrasion will increase the surface area for the mechanical bonding. So we start off by doing what? Doing a surface preparation. Now, the next step would be priming the porous surfaces. Priming the porous surfaces. Priming the porous surfaces. Okay, I'm writing in bullet point forms because where I'm actually writing, man, it keeps on flashing, and I don't want that. And it's also a bit of a challenge when I keep on writing here. So I'm just gonna, hit the key points, hit the key phrases, right? Then you can just fill in the rest on your own. Okay, but I'll try to provide some reasons as to try and connect all the points that I'm listing out here. So we are priming the surface now. This actually prevents the adhesive absorption, ensuring that full coverage at the bond line. Okay, at the bond line. So we are trying by all means that the adhesive that is going to be used for the adhesive that is going to be used for the cohesion is not absorbed by the material. So we're going to start off by priming the porous surfaces. So we're going to try to prep the surface by filling in those small holes on the surface, so that once we start applying the adhesive, none of it is actually absorbed, or all of it is absorbed. Most of it is left on the surface so that it provides enough contact between the combining materials. Okay, then from there we're gonna have a thin and even application of the adhesive. A thin and even application of the adhesive. Thick adhesive layers, they tend to cure unevenly, right? So we are trying to create a situation where the adhesive, when applied, it actually provides a sort of like an even layer of adhesive, and it is also thin. So if this is not achieved, this will create weak points and reducing shear strength of the cohesion between the two materials. All right, so this is another phrase that I think is key in the discussion or in the description of this question. All right, so we also have bonding both the surfaces. Now it's time for bonding both the surfaces. Bonding both the surfaces. Okay, so this will ensure that complete interfacial contact is established, right? Now this maximizes the chemical adhesion of the adhesive. All right, so I think another point that I can list here would be the curing under pressure. Now securing under pressure. Now that the two surfaces have been bonded together, now it's time to allow for the adhesive to start curing and securing the two materials once bonded. So this will maintain the intimate contact during the curing process. This will eventually, prevent air pockets and ensuring a continuous bond. So after bonding the two surfaces, they should be maintained in that position so that no air seeps in and compromise the bond between the two bonded surfaces. Now let's go to 2.6. Let me switch back to black. Now an earth return system is shown in the diagram below is needed for the electric fence to function effectively. We have an energizer here, a live connection, live fencing. This is also grounded to the earth. Alright, now for 2.6.1 they want us to briefly discuss the procedure that must be followed when testing the earth system of an electric fence. Okay, 2.6.1 discuss the procedure that must be followed when testing the earth system of an electric fence. Okay, now here's the important part. Here's an important point. Yeah, here's an important point. Number one, we need to short the live line to the ground. Short the lifeline to the ground, as they did here, to the ground, right? This will create a control circuit to test the earth performance. This is crucial. This is very, 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 very important. Very important, right? We are discussing, so you shouldn't list out in bullet point form. Just try to write in paragraph form, okay? You know my situation as I mentioned above, right? So I'm gonna hold the discussion like I did with 2.5. So for 2.6.1, I'm just gonna highlight the important points. Just fill in the gaps. Just use your own English to finish up here. All right. So next would be to energize and measure the voltage from after grounding. That is to energize and measure voltage. Now this would involve using a voltmeter between the ground and the earth spikes, right? A voltage reading that is greater than 200 volts would indicate high resistance, meaning that the earth system cannot safely dissipate charge, leading to poor fence performance and shock risks. Something like that. Yeah, something like that. But we start off by grinding, then we energize and measure the voltage, right? And measure the voltage. That is the procedure that is required to have an effective testing of the earth system. Okay, now for 2.6.2, give two examples where electric fences are used on a farm. Right, so I think that should be obvious, right? That should be obvious one. Predator and perimeter security of the farm. Perimeter security of the farm and rotational gazing management. rotational grazing management. I think these are 2 points that I can think of. All right, now for the last question, we have a 2.6.3. 2.6.3. Name 3 alternative energy sources that can be used to supply energy to an electrical fence. Okay, another textbook example. I mean, a textbook question here, right? So there's quite a few options here, but they are asking for 3. I'm thinking solar. I'm thinking wind energy, right? I'm also thinking okay, I'm saying it's easy, but now I'm stuck. I can only think of 2. What about hydro? I think hydro should work. Water, if there's a flowing river stream nearby, right? So the flowing water that is available can be used in conjunction with small turbines to provide consistent power, especially in mountainous farms and river or farms that are next to the river. This is appropriate for such cases. So another option would be water. Another turbine that is operated by wind can also be used. Solar requires the sun. So these are the 3 options that I can think of right now. So this is our 35 marks for question 2. Now for section B, the next part of our section B, that is question 3 involving energy. So for this question, we're going to be diving into energy basically and other sources of energy, right? We have sources of energy such as solar, wind, water, hydroelectricity. We also now have something called bioenergy as well. So we're going to be exploring those concepts in this question. So for 3.1 and 3.2, we are provided with sketches. So I'm expecting to be asked questions about these sketches. So for 3.1, there are parts that are labeled on the sketch. We have part A and part B, right? So we need to identify these parts and describe the function of each. Okay, that is why. That explains the 4 marks. Okay, it's fine. 3.1. Let's go ahead and answer this one. So A is what is it called? A propeller. A propeller shouldn't be a double P. It's a propeller type. It's a propeller type blade. Propeller type blade. Okay, this is a propeller type blade. Now, what is the function for this? All right, so propeller type blades are these large, aerodynamically shaped blades that are responsible for catching the wind during the production of electricity, right? So there are those spinning blades around the turbine. Okay, so their function is actually to convert the wind's kinetic energy into rotational mechanical energy, mechanical energy. So it takes kinetic energy of the wind and converts it into rotational mechanical energy, which leads us to part B, right? Whatever is happening on A is transferred to B. Now, B is that part that gives us energy, okay? It's that part that gives us energy. It is the generator. It produces the actual electricity, right? So the propeller, it only converts one form of energy to another, the kinetic to mechanical. Now the generator actually takes the rotational energy into electrical energy. So there's sort of like a three-step energy conversion: kinetic, mechanical, then to electrical energy. Okay, so its function is to convert the rotational energy, the rotational mechanical energy, into electrical energy, into electrical energy. So that is the function for part B. Now the solar hot water system shown below is used to heat water without using electricity. I'm sure you have seen these structures around on top of residential buildings, right? I think I've seen these ones over RDP roofs, and even in some of the urban areas I've seen such structures. So this is a solar hot water system. Okay, 3.2.1, explain the working of the solar hot water system shown above. 3.2.1. okay, so these structures or these systems, they actually follow what we call a thermosiphon principle, right? So it's just basically explaining that principle in this case, right? So explaining the principle, you actually explain how the solar hot water system is working. Okay. All right, so you know what, I'm just gonna use the bullet point system here, then you're gonna fill out the rest, but we're gonna discuss it. Reason being, my writing, it won't be as fast as I want it to be. So just like we did with question 2, I'm just gonna touch on the key phrases in our explanation for the principle or for the working of the hot water system. Okay, so there's that solar connection. Let's start off here. Solar connection. So this solar connection is where the sun heats water in what do they call them? In evacuated tubes, or the flat plate collectors, these plates, right? So solar connection, it's when the sun heats up these pipes. Okay, so solar connection, I think you can start your conversation here or your explanation here. Start by explaining how the energy is collected from the sun. It's through the pipes. Okay, it's through the pipes. Next would be to talk about the natural convection. The natural convection. Now, there's a heat exchanger. A heat exchanger transfers the warmth to household water without mixing. So the natural convection, so the heated water is now collected and transferred to the household without mixing. Okay, without mixing. Then we're gonna have this continuous circulation. Continuous circulation. We're gonna have a continuous circulation. There's gonna be the cooler and denser water that sinks back to the collector bottom, right? Creating a passive loop without pumps. So the cool water will exchange, will move, will sort of like move and get heated, right? There's going to be that continuous movement between the hot and the cold water. So there's going to be that continuous loop to keep on heating the water, right? So this is going to be a passive loop without any pumps, as I've explained. Now, no electricity is actually needed for this whole system to operate. It relies entirely on fluid density changes from the solar heating. So it's going to alternate between the hot and the cold water, just circulating until the whole system or the whole water captured is actually heated eventually. Okay. Now for the next question, the 3.2.2. They want us to name 4 benefits of using solar energy to heat water. I think it's because of its zero fuel costs. When setting up this solar heating system, like right after installation, sunlight is free, energy from the sun is free. So right after installation, you have the sunlight available. Unlike electricity, gas, or paraffin, it immediately starts working. All right, so it's gotta be zero fuel cost. So no fuel is required to operate this thing. So that is one benefit. Another benefit is that it is low maintenance. Low maintenance. Okay, so few moving parts. There's gonna be, for the solar system, there are no moving parts, or let me just say there are few moving parts, right? So this means that minimum servicing beyond occasional antifreeze checks are gonna be done on this equipment. So there's low maintenance for the solar. So this will also reduce grid demand. Well, this is South Africa. We have something called load shedding, particularly valuable during power shortages. If there's load shedding involved, the solar system, it actually helps. It sort of like helps the grid, right? Because not too many appliances are requiring energy directly from the grid, right? So this is an isolated system that only draws energy from the sun, so it does not rely on the grid. So it is a advantage when there's a load shedding involved, or at a time where we have load shedding. So the last point would be long lifespan. Okay, if your solar system is well maintained, it can last to about 25 years to 20 years, around that, with only 5 to 7 years of payback periods. Okay, so yeah, it is a good investment. 3.3, we have a geothermal energy plant that is planted for construction in the Northern Cape. We have to state or give two geological aspects that should be considered to determine the location of constructing a geothermal plant. A geothermal plant. I think we can start off by saying checking for volcanic activities nearby. Volcanic activities nearby. What else? It could be accessibility as well. Accessibility can be another aspect as well. So these are the two aspects that I can think of right now. 3.3.2, this was 3.3.1. Describe two advantages of using a geothermal energy plant. Okay, so first of all, it has minimal land use. That's an advantage. Minimal land use. Okay, so it requires a small surface footprint compared to solar or wind farms. So that is one advantage. Another one would be low emissions. Low emissions. Only steam and minor gases are released. So this means that it's far cleaner compared to other alternatives like coal. So low emissions. So these are the two advantages. Okay, there's another point that I'm thinking about right now. It can be base load power. This provides a 24/7 electricity, unlike intermittent solar or wind alternatives, because if you have solar or wind, if there's no wind, there's no energy, no sun, no energy. So this one, it has a base load power, right? It can provide you with 24/7 electricity. Right now, for the last question, 3.4, let's start with 3.4.1. Bioenergy is widely used as an alternative fuel for agricultural machines. Name two alternative fuels that can be manufactured from plant material. Okay, I'm not sure if I understand the question, because it feels like it is the same as the next one, but let's use black. Name two alternative fuels that can be manufactured from plant. Okay, that's gonna be ethanol as the first one, and another one might be something like biodiesel. Yeah, biodiesel, why not? Biodiesel is going to be another alternative. Okay, so ethanol comes from the fermentation of sugars from sugarcane or even maize starch, right? This thing can also be used for powering generators, pumps, and adapted vehicles as well. And on the biodiesel side, it's gonna be the transesterification. I'm not even sure if I'm saying that word right. Transesterification of plant oils. All right, so we have these alternatives. For the last question, 3.4.2, name two crops that can be used to produce biofuel. I think I hinted on some of them while I was discussing the above. Number one, sugarcane. second one can be maize, right? I did mention something about sugarcane for under ethanol, as well as corn. So that is maize and sugar cane. So there goes your 20 marks for question 3. Now let's jump to the next question. All right, here's question 4, skills and construction processes. All right, so this question 4 starts from 4.1 to 4.2, 4.3, all the way up to 4.6. It's all about the construction processes. All right, so for the first question, we are presented with a sketch that shows the nozzle of a MIG welding apparatus as demonstrated here. Right, so let me try using a pen. Stop texting and draw. Okay, so this is the nozzle, right? This is the nozzle. This is the nozzle. And then what happens during the welding process is that there's gonna be a feeding wire, right? And through that feeding wire, there's gonna be a shielding gas cloud that is created through that wire, right? And we have a copper welding tip here. All right, so these are just the basic components that are shown on the sketch, right? So this is a MIG apparatus. So for the 4.1.1, they want us to describe the origin and purpose of the shielding gas cloud that forms around the welding area. Okay, so the shielding gas cloud is very important during this welding process. Number one is that the puddle that forms, the molten puddle that forms during the welding process, the shielding gas is responsible for protecting it, right? But we need to describe its origin as well as its purpose of the shielding cloud gas. I think I already gave the purpose for the shielding gas, right? So where does it come from, and what purpose does it serve? That is what we should be discussing here, right? So unlike the previous questions where I was using freehand to answer the questions, for this particular question, I think how about we're gonna type this time around. Okay, so for 4.1.1, let's talk about the origin. The origin. So the origin is that the inserted gas is fed through the pipe. Is fed through the pipe and nozzle, and exits through the holes in the nozzle. Then we can continue, perhaps providing the purpose as well for that gas. The purpose is to shield the molten puddle from oxygen contamination. Perfect. Contamination. All right, let me try breaking this down a little bit. Now, the shielding gas is, typically a mixture of argon and carbon dioxide, which comes from the cylinder of the MIG apparatus and travels through the welding torch, yes, and creates sort of like it's actually not a a visual cloud, right? It's somewhat invisible. It's a cloud that is invisible. It's there, but not clearly visible. And that cloud, that created cloud around the welding area, this is not just for show, right? It has importance. The shielding gas has importance. Is that when the metal gets super hot during the welding process, it becomes chemically reactive and can easily combine with the oxygen and nitrogen, which are gas elements found in the air, right? So the shield gas, it's protecting that puddle from the surrounding gases. So that contamination will create a wick as well as a brittle weld that is full of pores, right? So the gas cloud acts like a protective blanket, keeping atmospheric gases out and ensuring that we get sort of like a strong and clean weld each and every time we weld, each and every time we do a weld. Okay, so that's 4.1.1. So for 4.1.2, should I leave? No, let's tap 4. Okay, back. Okay, explain the procedure that must be followed when the feed wire bends onto the copper welding tip. Okay, this is a procedure that needs to be described, right? So first of all, what you should do is to release the trigger. Let's start there. Release the trigger. Release the trigger. Next step would be to use pliers and cut the blob from the welding tip. To cut the blob from the welding tip, the blob that forms at the tip of the welding tip should be cut out. Okay, then a next step would be to use a file and file the end of the welding tip and finally ensure the welding ensure the feeding wire, let's say feeding wire, is separated from separated from the tip and continue welding afterwards. Well, this is a common issue that every welder faces. So when the wire fuses to the tip, it's usually because of too much heat buildup or incorrect settings with the machine. Yeah, so the key here is don't just yank it out, don't just take it out, make sure you cut it away with pliers. This will prevent damaging the delicate copper tip. Yes, so this is very important because also the filing restores smooth wire passage, like or just think of it like clearing a blocked pipe. Skipping any of these steps that are listed here can lead to inconsistent welding and can also damage the equipment. So make sure you just keep some spare tips handy for quick changes during a welding job. Alright, so that's 4.1.2 for us. So for 4.1.3 we need to name three circumstances that can cause the feeding wire to melt onto the welding tip. Feeding wire to melt onto the feeding tip. Okay. 4.1.3. 4.1.3. All right. So I'm thinking heat management on this question. I'm thinking heat management. So when the nozzle is too close, so you are welding too slowly, in many cases the heat concentrates at the tip instead of the working piece. So it's like holding a lighter in one spot. Eventually something is going to melt, right? So here we want to give two circumstances that can cause the feed wire to melt onto the welding tip. So let's start here. How many do they want? 2. Okay, only 2. So for 2 points. Okay. So it can be anything from, a wire feed becoming too slow. That's point number 1. And then, like I mentioned, building up too much heat on the tip. They're only looking for 2, so I think this is sufficient enough. So the wire feeding speed needs to match your travel speed. So that is the main idea with the first point, the wire feeding becoming too much slow. So you need to match your traveling speed. So too slow and you are basically cooking the wire at the tip. So you need to match your speed. Okay, so for 4.1.4. Okay, so for this question, they are asking us to name 3 causes of cracks forming on the welding head when performing MIG welding. Just only 3 causes. Alright, so welding cracks, what are they? Welding cracks are like fractures in bones. Né? So instead of having a fracture on the bone in the welding, for welding, it's like having a crack on that welded area, right? So, they normally start small, but can cause complete failure under severe stress. So this means that parts can't move freely. So when welded, they cannot expand and contract naturally. So they can crack under stress. So think of welding a thick tractor frame. If you don't preheat it, the sudden temperature change is like pouring boiling water into a cold glass. It's gonna break, obviously, right? So a proper technique, correct settings, sometimes even preheating are your best defenses against something like this. So we only need to mention 3 causes for cracks in welds. I think I did mention, but something comes to mind like incorrect composition of electrode, and to some extent maybe a deep narrow weld head, or something like maybe Yeah. Okay. Something like providing a current that is too high. That is too high. So that's our 4.1.4. They only wanted 3. Only 3. 4.2. Heat has an influence on the amount of shrinking that occurs in a metal during the welding process. 4.2.1, they want us to describe shrinking as it occurs in a welding joint. So yes, now let's go for 4.2. Perhaps I can go here. 1. Okay, so describe what shrinking is. So this is like a fundamental physics applied to welding. This is basic physics, but think about it. When a metal expands when hot, and then it comes back and contracts when cold. That's the catch here with shrinking. So when a metal is heated, it expands, and when cooling down, it shrinks. You know what? Let me just go ahead and describe this thing because I have an idea of what to do with this question. Metal. I thought of providing a definition, but they want us to describe, not define. Okay, so metal expands when hot and contracts when cool instead of cold. When cool, but okay, but instead let me say but the weld area cools faster than the surrounding metal, then creating uneven contraction, uneven contractions, something like this. Okay, so this is how I would describe this thing. Now for 4.2.2, make a freehand drawing to illustrate the longitudinal angular shrinking on a welded project. The dimensions of the 2 flat bar pieces that must be welded together is 50 millimeters by 10 millimeters by 100 millimeters. The following must be included on the drawing: 2 pieces of metal, a welding head, a longitudinal angular shrinking, change in the shape of the metal. Okay, so this sounds like you need to, okay, let me just exit this out. Okay, it sounds like you need to draw to prepare something a bit professional here, but don't worry. This drawing, actually, they are not looking for your artistic skills here. They're just checking your understanding of the distortion patterns during the welding, right, on a welded project. Okay, so the key here is showing how 2 flat bars don't stay perfectly aligned after welding, which is sort of like a normal thing in the real world. So the angular shrinking means one end pulls up or down. It's not perfectly straight. some parts are up or bended up or bended down, right? So we're gonna try to prepare a sketch, also label it, and sort of like try to exaggerate slightly the distortions so that it is obvious that we know what we are demonstrating here, right? So those are just the key points or key ideas to keep in mind when preparing such a sketch. Okay, so I'm gonna do it freehand this time. Okay, I think I'm gonna keep the blue, but first I'm gonna try to prepare the welded area, the area that connects the two flat plates. Okay, so this is the welded part between the two metal plates. Then I'm gonna use maybe black to represent the other part, or one metal part, and then it's gonna look something like this. I'm gonna create sort of like a bend in the middle to create that distortion illusion. Okay, so maybe for the other piece, I think let's keep the black going, and we're gonna have something like this and connect it like this and have that bended area again. Okay, so they want us to show what? The welded head, which we do have, by the way. It's this. Label it as the welding head. The welding head. Now we need the longitudinal angular shrinking. Okay, so this is the longitudinal angular shrinking I was referring to. These parts, they are not they don't go in a straight line, but they are bended to some degree. So this is the longitudinal angular shrinking. So in the real world, you're not gonna have something perfectly straight, so it's gonna have that angular shrinking area. So these are the two pieces of metals, 1 and 2, and changing the shape of the metal. So yeah, ne? All right, let's have maybe something a bit reddish, so, and do some dotted lines like this and something like this, just to show that the original thing looked somewhat like this. Now that it's welded, it's gonna look like that black sketch that I prepared. So this is how far I can go, guys. This is how far I can go, but it's still a pretty good sketch. I hope. So they are not looking for something amazing, just something that gets the point across. Okay, something that gets the point across. So let's go to 4.2.3. State two measures that can be taken to prevent metal from distorting when welding is performed. You have these two metal plates that are being welded. I tried demonstrating or drawing the situation where the original state, which in this case it's the red framework, it's the original structure, right? But after welding, it's gonna shrink a little bit, right? It's gonna get distorted. Now, whether we like it or not, this will always take place. We want to come up, or we want to state ways in which to reduce this effect. That is what 4.2.3 is all about. Okay, so I'm gonna stop drawing and go back to typing. So for 4.2.3 we're gonna state. Okay, so okay, how can I approach this one? Okay, so these measures are sort of like your toolbox solutions, right, for the distortion control of the welding. Okay, so I don't know, I'm thinking by clamping, or clamping your material perhaps properly. Yeah, that's a good one. Okay, and doing some presetting. I can go, as well as maybe something like spot welding. It's gonna work. All right. So the presetting simply means that we are deliberately positioning the pieces slightly off, right, so that the shrinkage pulls them into alignment. So we are purposely sort of like misaligning them, right? Sort of like misaligning them, so that once the welding is done, the welding is gonna give them the correct position. It's gonna put them into a better position, right? So on the other side, the clamping is gonna hold everything rigid during the welding. So it's sort of like these are just two. There's also spot welding. There's also doing patchwork as well, right? So it's not just two things that should be done. It's just a sort of like a it's not only two. There's other means or other ways of achieving this, right? So, and they all work hand in hand. Okay, so you shouldn't just do clamping and presetting only. So there's other ways, but since the question only is looking for two measures, I'm just gonna list them out. But just to go a bit further, just to explain the whole scenario, the whole idea here is that the spot welding, on the other hand, can create sort of like a temporary tags, right? Tags that hold the alignment before the final welding, right? It's like sort of like pasting a garment before sewing, right? Get everything positioned right first, right? Get everything in position first, and achieving the rest of the things that I've listed, then you start welding, right? You need to set your equipment and your position of the material that you are trying to weld. Then you start welding. Then you won't have that that distortion when welding. All right, now let's go for 4.3. The illustration below shows an oxyacetylene set. Oxyacetylene set. Okay. When working with such equipment, when working with things like oxyacetylene, safety comes first. Whether you are welding or doing anything related to construction, safety comes first, guys. Safety comes first. So here they're asking us, why is the use of sunglasses is not recommended when cutting with oxyacetylene set. Now, what they are asking us here is a very, very, very important safety point. Sunglasses might darken the visible light, But oxyacetylene cutting procedures, intense ultraviolet radiation can cause the arc eye. So it's sort of like a painful condition like sunburn in your eyeballs, right? So proper welding goggles have that are specifically coated that have specifically coated lenses that block these harmful rays. So you're not just gonna use any sunglasses that you have maybe in your wardrobe, or that you bought, I don't know, maybe at Markham's or somewhere. You're not going to use just any sunglasses. There's a special kind of glasses that are used when doing welding or using something like oxyacetylene. So proper welding goggles are required. Plus the sparks they are at a higher temperature, which can melt the sunglasses that you decided to use. All right, so it is important that we use the right PPE. It is important that we use the correct PPE, not just anything that you find. The correct PPE is very important. So sunglasses, we haven't answered the question. So 4.3.1, the sunglasses, they will not filter the UV light effectively. Number one, effectively, and they will also not be able to protect your eyes against flying sparks. Yeah, flying sparks, not spots, sparks. Okay, so next question, 4.3.2. Describe the possible outcome for the gas cylinder if it accidentally topples over. Okay, if it topples over. So a falling cylinder can snap off the valve, number one. This will also release the gas at explosive pressure. So if it falls or if it topples over, something like this might happen, right? So the cylinder can become sort of like a rocket and shooting through walls. So these are real incidences where it has caused fatalities as well. I haven't seen a situation like this, but I read about the such situations. That's why cylinders are always chained upright. It's important that they stay in a firm position, not just tidy storage. It's also a life-saving protocol, right? It's also a life-saving protocol. This is not just to sort of like keep it in one position. It's just to give it stability so that it doesn't topple over, it doesn't topple over. So number one, 4.3.2. all right, so the main valve may break off when it topples over, and the cylinder will turn into a missile, and course devastating damages damages okay, damages, devastating. Cool. Okay, so that's 4.3.2. So for 4.3.3, name two types of metal that can be cut with an oxyacetylene welding set. There's several, but they are looking only for two. So the first one can be mild metal, and cast iron as well. Cast iron. All right. So there's several. There's mild metal and cast iron. There's also stainless steel as well, and carbon steel. Yeah, carbon steel. Now, I want you to understand something here. Right? I want you to understand something. Metals such as aluminum, copper, and brass, oxyacetylene works on ferrous metals because the process relies on oxidizing the iron. So the flame hits the metal, then pure oxygen is added, reacting with iron to form iron oxide, which melts at a lower temperature. Now, what did I say? The oxyacetylene works on ferrous metals. Your mild metal, your cast iron, your stainless steel, as well as your carbon steel as well, right? They are examples of ferrous metals. So non-ferrous metals like your aluminum, your copper, and brass don't oxidize the same way. They don't create that slag, that iron oxide. So you need different cutting methods for the other metals, right? I was sort of like trying to contrast between ferrous and non-ferrous metals, and just to demonstrate that it doesn't oxyacetylene doesn't work on all metals, right? Only on ferrous metals. For non-ferrous metals, you'll have to opt for a different cutting method. For 4.4, they want us to give technical advice to a farmer who wants to purchase a plasma cutting machine for general use on the farm. Okay, this is practical business advice. So plasma cutters are rated by thickness capacity. Let's start there. So buying too small means you can't cut your materials. Too large, you can waste a lot of money as well. So the compressor is often overlooked. So plasma cutting needs clean, dry air at constant pressure. So a cheap machine might save money up front but cost more in down time and consumables. So for farm use where reliability is key, quality is gonna matter here, right? So the farmer needs advice. So I would say buy a machine according to the thickness of the metal to be cut. Number one, the thickness of the metals you are normally working with on a daily basis, right? So another point or another thing to think about would be a compressor large enough for the required working pressure as well. So as well as a quality brand, a well-known and a quality brand. So buying a machine according to the thick. Okay, I would advise the farmer to consider buying a machine according to the thickness of metal to be cut. He will also need a compressor that is large enough for the required working pressure. I think this is good advice. I'm gonna stop it here. All right, so 4.4. 4.5, name 4 items of personal protective equipment that must be worn when doing plasma cutting. Okay, all right. 4.5. Let's see. Yeah, bring it this side. Okay, so 4 items. Come on. This is textbook. Fireproof gloves. You are working with fire. A face shield to protect your face. Okay. A face shield to protect your face. What else? Flame resistant clothing. You are working with flames or fire here. Flame resistant clothing, gloves, clothing. Next up, always use leather shoes. These are just 4. So we are dealing with plasma cutting. So plasma arcs can reach as high, temperatures as high as 25 degrees Celsius. Imagine sticking your finger to such amounts of temperatures. You're gonna burn right there and then. So that's hotter than the sun's surface. Imagine, that's hotter than the sun's surface. So regular workshop gloves won't cut it. So the face shield protects not just from sparks but from the UV radiation coming from the plasma. So notice that I've also listed out leather shoes, not just closed shoes, because the molten metal droplets will burn through synthetic material. So strictly leather shoes here. This is a minimum protection. Many professionals add even aprons while performing the job. I've seen instances like this where someone working at a workshop is fully equipped, as the full PPE, but just the apron is an added layer, or just for extra protection, right? I wouldn't say optional. If you have it, just wear it, right? Just wear it. And then also hearing protection and proper ventilation too. These are just some more measures that you can take into consideration when doing a plasma cutting. Okay, so for 4.6, state 2 factors that cause poor cutting performance when using plasma cutting machine. State two factors that cause poor cutting performance when using plasma cutting machine. You know, most plasma cutting problems, they normally trace back to air quality and pressure. So water in the line causes erratic arcs and ruins consumables fast. So worn parts are the number one cause of poor cuts when it comes to cutting with a plasma machine. All right. So I'm thinking. They only want two factors, right? So water, that's the first one I can think of, in a system, and then a second one would be a worn out electrode and tip. A worn out electrode and tip. They only want two, so this is the two. These are the two factors. Or even blocked air filters. So these are the two factors that can cause poor cutting performance. So let's go for the next question. Question 5. Tools, implements, and equipment. Now, this is a section that really tests your practical farm knowledge. We're going to go from basic tools to some complex machinery, and I'll be walking you through every question throughout question 5. Okay, now let's do this. 5.1, specialization plays a crucial role in the management of a farm to ensure success in the agricultural sector. Okay, now for the first question, they want us to name two disadvantages of farm mechanization. Okay, so this might seem against your intuition. Why would mechanization, which is supposed to make farming more efficient, have more disadvantages? Now, let's try to unpack this a little bit before we even answer this question. But first, maybe I should do this. Let's get typing. Okay, so that is 5 point. Come on. Okay, 0.1.1. So that's the first question. We need two disadvantages of farm mechanization. All right, so let's start with high initial cost, which is an obvious one, right? Because something like a new tractor, getting a new tractor can cost more than a house, for example. But as a hidden cost, stuff like skilled operators, they demand higher salaries. So you can just put anyone on a 2 million combine harvester as an example. So as farms evolve to a more mechanized, right? I'm looking for the right term. I'm trying to pronounce this term correctly. Mechanize. As a farm evolves to a more mechanized state, meaning that you don't require too much labor. You are using machines to do most of the operations at a farm, right? So fewer and fewer skilled workers are gonna be needed. So that's another thing that will cause disadvantages, right? Because there's gonna be a loss of jobs. Okay, it's gonna lead to job losses, more especially in rural communities where agriculture is often their main employer. So this creates a social and sort of like an economic challenge that goes beyond the farm gates, right? That goes beyond the farm gates. So two disadvantages. High I'm thinking high initial costs. High initial costs, as well as job law as well as job losses. 5.1.2, give two examples of fixed capital on a farm. Okay, fixed capital. What is fixed capital? What is fixed capital? How do we define fixed capital? Let's start with the definition first. All right, so learning the key concepts in many cases is gonna save you the hassle of having to memorize stuff, right? So knowing the definition in many cases can help you get answers a bit more faster, right? So know your definitions. A fixed capital can be, or a fixed capital refers to assets that can't be easily moved or liquidated, right? So they are literally fixed on the farm. Stuff like land, buildings, boreholes, kraals, pumps, the list goes on and on. Okay, so two examples of fixed capital can be the land on which you are farming on. It's a capital, it's a form of capital. Buildings, those are the two examples of fixed capitals on the farm. 5.2 for 5.2, state two functions of a shear bolt used in the drive system of a baling machine. Shear bolts in baling machines. Okay, shear bolts are the agricultural equivalent of electrical fuses. They are designed to fail first to protect more expensive components. Keep that in mind. So they just need two functions here. Yeah? Two functions. So this normally prevents heavy objects from being taken into the baler. Okay, let me fix some of the words here. Okay, this can be one. Protects the pickup if impeded. Okay, if impeded. So say maybe when something like a rock gets into the baler, right? The shear and bolt breaks instead of damaging the gearbox or a drive shaft. So it is normally cheaper it's normally a cheaper and replaceable safety device. So farmers should always carry spare shear bolts. A broken one can save you thousands in repairing costs. So it's a good idea to have these on the farm. Alright, so 5.3. Label the three parts of the clutch assembly A, B, and C as shown in the photograph below. So we have A, B, then C. Alright, let's label that. A, that looks like a pressure plate. That's a pressure plate. And then let's label B. B, it's a release bearing. A release bearing. C, that's gonna be a clutch plate. That's an obvious one. A clutch plate. Clutch plate. Okay, understanding these three components is crucial for anyone maintaining farm vehicles. Okay, so it is 5.4 locked differential and turning. Is it possible for a vehicle to turn around a bend if the differential is locked? Explain your answer. 5.4. Okay, this is fundamental mechanics. Okay, so when you turn a corner, the outside wheel follows a large radius and needs to rotate faster. I'm trying to paint a picture here. So a differential allows this speed difference. If it's locked and you find that both wheels are forced to turn at the same speed, this will cause wheel hop, tire scrubbing, and potentially damaging the drivetrain. So in farming, differential locks are used in straight line traction situations like plowing, but they must be disengaged for turning. All right, for turning. So just to answer the question, I would say no, because because when turning, the outer wheel must travel faster than the inner wheel, which cannot happen with a locked differential. Come on, differential. Full stop. All right, 5.5. Give two advantages of using a bearing in a drive system. So let's bring it down a little bit. I don't want co-pilot. Come on. Okay. Right, so let's go for 5.5. Let's use black one, the blue thing, that blue stuff. Let's go back and let's select black. Okay, so 5.5, two advantages. Okay, all right. Give two advantages of using. Okay, so just for 2 marks. You know what? Bearings increase. They normally increase efficiency, and they also allow expanded speed operation, expanded high speed operation, full stop. Alright, these are the two advantages. Okay, these are the two advantages. You know, without bearings, metals would grind against metal, creating immense friction, heat, and rapid wear of the driving system. So this is very crucial to it's a very important thing to have. Okay, so 5.6 name two benefits of thermoplastic universal joints. Okay, all right, so okay, thermoplastic universal joints. So these are more like replacements for the traditional metal U joints. So they are lightweight, which reduces rotational mass, improving efficiency as well. So just to name the benefits, I would say they are lightweight. They are lightweight, and have negligible negligible backlash. That's 5.6. 5.7, make a neat freehand drawing of a ratchet type slip clutch and indicate the following components: ratchet plate, pressure spring, driven gear with ratchet plate, adjusting nut. Yeah, ne? Okay, so doing these sketches can be a bit of a pain in the behind, but now I'm just gonna do a quick one, just to demonstrate what it looks like. I'm sure you can find something like this in a textbook, right? So something like this, there should be a groove like this, and then we're gonna have something that almost fits into that groove like this, and then have something that looks like this. You know what, your sketch might not look something like this, but you know, just draw something convincing rather than, you know, then you're gonna have your nut like this, something like this. Okay, so then you have your what is this? The driven gear with ratchet plate. It's this part here, and then you have your pressure spring. Pressure spring goes here. You have your pressure spring and an adjusting nut, and then you're gonna have your ratchet plate somewhere here. So that's 1, 2. So yeah, you need to label all the 4 components as well, so that you get your full 4 marks. Now let's go for the next question, 5.8. Back to typing mode. Alright, so explain to a tractor operator why it is better to move heavy loads with the rear forklift rather than the front forklift as shown in the picture below. Just give yourself time to study the picture that is given. In any case or any scenario or a question where you are given a picture, just give yourself time to fully analyze the picture. So if you take a look at the shape of a tractor, the front wheels are smaller in size compared to the ones in the rear. So the rear wheels on the tractor are larger, heavier, and specifically designed for carrying loads. The front wheels are for steering, lifting heavy loads at the front raises the the center of gravity dangerously so, and unweighs the rear wheels where the engine weight is. So I would start off by saying that so that's 5.8, come on, 5.8. So I'm gonna provide a reason by saying that the rear wheels are okay on tractors are larger larger, heavier, and are designed to carry loads. Yeah, to carry loads. Meanwhile, the front wheels are for steering. Then maybe you can take it a bit further by mentioning the center of gravity and stuff. So yeah, that's our 5.8. Describes what happens when the top link between a tractor and a plow is removed when plowing. That's 5.9. Okay, so the top link sort of like creates a three-point linkage system that controls implement depth and angle. So removing it turns it into a 2-point system that is unstable. The plow will either sort of like dive too deep, lifting the tractor's front or right out of the ground. Okay, so just to put it in summary, the 5.9, we can do the following. We can say maybe the back of the plow will tend to lift up out of the soil or the nose of the tractor and will tend to lift up. Full stop. Okay, then we have 5.10, where we are asked to name the connection points on the tractor where the quick coupling mechanism shown below should be connected. Where it should be connected, it's gonna be the top link, of course, the top link, and the two lifting arms, I believe this is the last question. Of course not. Yeah, the question 5 is I think it's the longest question on this paper. So name 3 systems on a combine harvester that must be set or monitored to limit the loss of maize kernels during the harvesting process. Okay, a picking up system, must be set up correctly. Yeah, correctly. First things first. All right. So okay, you know what? Harvesting males is sort of like a balancing act. So the pickup reel must match ground speed together all or every stalk without beating the kernels off. Alright. So the drum speed must stretch the kernels without cracking them. Right? Without cracking them. So I'm thinking um as well as maybe um correctly setting up the sieves and drum speed and drum speed that is well regulated. Nice. All right, then 5.12. Hammer mills that vibrate will not last long. Name 3 preventive measures that you must implement to keep a hammer mill from vibrating. Okay, so hammer mills the hammer wheels, the hammer mills, they sort of like spin at incredible high speeds, thus creating sort of like an imbalance, um, right? And this will eventually cause these vibrations. Okay, so we should have hammers with equal mass so that we don't have this imbalance, right? Make sure that let's say a correct operating speed is achieved. And then what else? Yes, proper anchoring. The proper anchor is also another thing to consider. Indicate 2 places on a tractor where an automatic depth control mechanism can be installed. In differential housing, I think yes, it should be in the differential housing. And the differential housing, how many do they want? 2 and at the base of the lifting arms. Then 5.14, state 3 advantages of using transmission oil in a tractor hydraulic system. So okay, there is good cooling qualities. Good cooling qualities um, it okay, it is relatively cheap. It's relatively cheaper. A third one, it provides good lubrication qualities. I think let me leave it at that. Let me just leave it at that. Okay, I can exit here because we're gonna have a calculation next. Okay, so for the last question, 5.15, a diesel tank with a surface area of 9 square meters. So the whole diesel tank has a total surface area of 9 cubic meters. That needs to be painted. Use a corrosion preventative paint with a covering capacity of 3 square meter per liter. 2 coats of the paint are required on the tank. Calculate the amount of paint required. Show all calculations. Now, going back to writing 5.1.5. I love this part. Calculations. It's my thing. Area is 9 square meters. Alright. Then we also have a coverage of 3 square meter per liter. So the coverage simply means that the paint that you're gonna apply, a liter of it, it's gonna cover 3 square meters, right? 3 square meters. Now we want to figure out how many liters. Now remember, we want to find how much of the paint is required to do the job. Okay, keep in mind keep in mind how big is the area. It's 9, right? But the paint that we're gonna buy or use has a coverage of 3 square meter per liter. So let's find out how many liters are we going to need or require to do the first coat. So for the first coat, we normally take the total area and divide it by the coverage rate. So that's gonna be 3. So it simply means that we need 3 liters to cover or do the first coat. Okay, so since we are doing 2 coats, we're gonna say for 2 coats this is gonna be equal to, so this 3 liter, it's only for 1 coat for the whole diesel tank. Now for 2 coats, we're gonna say 2 times the amount of liters required for the first coat. So that's gonna be 6 liters in total. 6 liters in total. So that's our question. Right, question 6. This is the last section of the question paper. It's based on your water management. So let's wrap it up. Now this section, it's gonna test you on everything from irrigation systems to water purification, covering both the practical farming applications and your technical knowledge as well. Alright, so 6.1, they want us to complete the table regarding the different irrigation systems. So we need to write only the answer next to the question numbers. Okay, so for 6.1, we have to give a name that relates to the explanation and the material as shown on the table. So the explanation is that the sprinkler irrigation consists of several segments of pipe joined together and supported by trusses mounted on wheeled towers with sprinklers positioned along its length permanently fixed to a middle point. Okay, for this one it's gonna be, let's write it here, 6.1.1.1. let's just write it here. All right, this is gonna be a center pivot irrigation, then 6.1.2. Alright, we have hydroponics, a system utilizing sprinklers that are permanently installed. 6.1, what material is used? It's normally PVC pipes. With plastic or brass sprinklers. Did I write that correctly? Yeah, sprinklers. Alright, so your hydroponic system is usually made out of PVC pipes or even sprinklers made out of brass. 6.1.3, really, are they expecting us to write a explanation for this? But anyway, so we have a traveling gun sprinkler. 6.1.3, we need to give a function, working, or an explanation. It's polyethylene tubing and steel drum. Okay, so these sprinklers irrigate areas such as small farms, parks, and pastures. So these are sprinklers that can irrigate areas such as small farms, parks, and pastures. Okay, and pastures. Okay, let's go to 6.1.4. 6.1.4. Okay, we need to give a name. A series of pipes, each with a wheel of about 1.5 diameter. Sprinklers are along its length with an engine installed at the middle of the pipe. Okay, coupled material, coupled aluminum pipes. What is this? Okay, all right. Okay, these are wheel line irrigation. Yes, irrigation, wheel line irrigation. All right, so this table was actually testing your ability to match irrigation systems with their descriptions and materials. So for the center pivot irrigation, it's that iconic circular system you see from airplanes. It rotates around a central point covering large circular areas. For the hydroponic, I think this one was a bit tricky, but I'm confident with that 6.1.2. It's not actually a sprinkler system, but rather a soilless cultivation. And then for the traveling gun systems that are mobile, they drag a hose and cover irrigations. Okay, no, I'm confident with this one, but it's just it was basically a test on your knowledge for irrigation systems. Let's jump to 6.2. Disadvantages of full flood irrigation systems. Flood irrigation systems. Okay, 4 disadvantages. Disadvantages of using flood irrigation systems. Okay, flood irrigation is an ancient method, but it's also problematic at times. First, it needs lots of water constantly available, and this is not practical during drought periods, right? So the gradient issue is also critical. Too steep and water runs off, causing erosion. So the disadvantages will include such things as drainage problems. Um, okay, it also requires a strong supply of water. I think we can say that. How many? 3. Here's the third one. So the erosion can also create or increase the soil salinity. I think we can include that one as well. Alright, so yeah, so as water, okay. Alright, 6.3. Name the function of each of the following parts of an irrigation system. So for this one, let's exit this and come here and provide the function. Name the function of each of the following parts of an irrigation system. We have a scent filter, a sprinkler, a pump, a solenoid valve, one-way valve. Do we have anything else? Nope, it's only these 5. So we wanna provide functions for each. So a scent filter, I think this one, it's an obvious one. It prevents blockages of the nozzle. What about the sprinkler? The sprinkler provides water, so it emits water to plants. A pump, the pump provides water to the system, so the pump is sort of like the heart of the system. So it does what? It provides water to the system. And then the solenoid valve, it is responsible for the flow of water. The last one, it prevents backflow, so it prevents the water from going back. Prevents the backflow of water. Okay, so these are the functions. Easy 5 marks. So the photographs below show devices used in irrigation scheduling. Name devices A and B. 6.4. So the A, 6.4.1, component A, that is a tensiometer. And then the B component, what is that called? an evaporation what tank pen, I mean evaporation 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 pen. So the tensiometer measures what soil moisture tension, like how hard plant roots must work to extract water. It's like a sort of like a thirst meter for your soil. The evaporation pen measures how much water evaporates from an open surface. Okay, okay. It's not like they asked us to explain them. I'm just trying to provide some context to the question. Okay, so let's go to 6.4.2. Alright, what is the main purpose of the devices shown above? Okay, so both devices help answer when should I irrigate and by how much. Hear me now. Both of these devices help us answer the following question: when should I irrigate and by how much? They prevent both underwatering and overwatering. So, you know, if you are a smart farmer, you can use these tools to irrigate based on the actual need, not just a fixed schedule. This can actually help you save on water as well. So for the 6.2, what is the purpose? To determine the water evaporation rate in a specific field. To determine the water evaporation rate in a specific field. 6.5. 6.5. Name two devices that are used to control garden watering systems. Okay, we have the mechanical timer. We also have the electronic irrigation timer. Both mechanical and electronic irrigation timer. Alright, 6.6, describe the operation of a septic tank drainage system. Alright, the septic tank drainage system, it's sort of like a two-stage biological treatment system. Yeah, let's call it that. The first tank is where solids settle and bacteria break down waste. No oxygen here. There's no oxygen in that tank. The second tank allows further settling. By now, the waste is mostly liquid. So the stone trench provides a final filtration before water enters the soil. So for critical maintenance, regular emptying of solids and never putting chemicals down the drain that kill the essential bacteria. Okay, so that's the best description I can provide for this one. Okay, so should I type this one out? I don't know. Right, let's say describe the operation. We can say this system is a two-stage biological treatment system where the first tank is where solids settle and bacteria break down waste. The second tank allows further settling making the material to be mostly liquid. You can just continue by adding your own imagination to the answer, right? I'm not going to provide the whole thing, but I think I just gave away the answer for 6.6. 6.7, name 3 points to consider when identifying a suitable location for the installation of a septic tank. Okay, septic tank. Number 1, should not be placed near boreholes or drinking water site. So these things can create some an awful smell. So another thing to note here, should be placed far away from a household. I think we can also say should be placed far away from pastures as well. We can say should not be placed. I think we can use this one as well. Should not be placed near where people eat or work. They are only 1, 3. For the 6.8, describe the operation of a pipe drainage system. Alright, the pipe drainage system, you can think of it like a river system. Think of it as sort of like an underground river system that you create. The gravel allows water. The gravel or the material found underground can be seen as allowing water to enter while filtering out the soil, right? So we can just say water drains through surface gravel, then sips into the pipes perforations and travels out the pipe end to accommodation areas. I think this suffices 6.8, 6.9. Name 3 types of water purification systems that use a membrane to purify household water. To purify. Okay. So I have this one at my place. The one I can think of now, it's reverse osmosis. Oh yeah, then we also have the whole house purification. Then for the last one we have the inline filters. The end. This ends our question paper walkthrough for this 2018 question paper. Okay, so question 6 was the last question for this paper. Thanks for tuning in, guys. Thanks for watching. Don't forget to share, like, subscribe if you enjoy the content. After subscribing, don't forget to push the notification bell so that you get notified for any content, for all content that I create in this channel. I would appreciate that. I'll catch you on the next recording. Bye bye.